Find the difference quotient for the following. Now, in order to successfully do that, you have to know what the difference quotient is, what that looks like. So the difference quotient for f of x is given by the expression f of x plus h minus f of x all over h. So when you're working with the difference quotient, f of x is given, h is just h, it's just the second variable that we have to deal with, and f of x plus h is the only thing we really need to figure out. So you can't tell by looking at this, but your goal here is to cancel h, or reduce away h. So like I said, we need to figure out what f of x plus h is. So in order to do that, I'm just going to come over here to part A, and I'm going to figure out what is f of x plus h. Well, you just got done seeing, if you've seen a previous video about function evaluation, this. That whatever is inputted for x will also get inputted for these x's as well. So here will be x plus h, and also over here x plus h. So now it's going to follow a very similar format to evaluating a function. You'll want to distribute this out, or FOIL, and multiply all of the insides of that foiling by 2, which gives you 2x squared plus 4xh plus 2h squared. You can distribute a -1 here to give you negative x minus h, and finally the plus 4 comes along for the ride. So all of this pinkish purpley part here is f of x plus h. So if I'm looking over here at the difference quotient, I can see f of x plus h will be all of this stuff, minus f of x will be all of this stuff, and that will all be over h. Just like this fraction right here. F of x plus h is all of this pink stuff here, minus f of x is what we were given, and h is in the denominator. And our goal is to get rid of this h. Well, we can only get rid of this h if we have an h in the numerator. Currently we don't. But we can get an h in the numerator. That comes with simplifying what's in the numerator. The short way to think about it is that any terms without an h in them will cancel out. And I'll go through that the first time around to show you. So 2x squared minus 2x squared. If you subtract something from itself, it cancels out, you get 0, reduces away. You have, let's see here, minus x, negative x, minus another negative x, subtracting something from itself. So long, and the same thing with the positive 4. That leaves you with what left over in the numerator. 4xh plus 2h squared minus h, all in the numerator. All of that will be over h. And this is important. You see all of the terms that didn't have an h are gone. That means all the terms that are left have an h, right? Since we're trying to reduce this away, we need an h in the numerator. Still don't have it, but we can make it now much easier than we could in the last step. Every term has an h. That means you can common factor an h out of the numerator. So this is h times 4x plus 2h minus 1 all over h. Now there's an h in the numerator that is a factor. Reduce, and you get a final answer of 4x plus 2h minus 1. I'm going to stop talking for a few seconds, give you a chance to pause the video and try part B for yourself. Here's a hint. You will need to use an LCD. For part B down here, f of x plus h, which you need to figure out before you can do anything else, is just 1 over x plus h. So in the a difference quotient expression, we have f of x plus h, which is just 1 over x plus h, minus f of x, which is 1 over x, all over h. You multiply the entire numerator and entire denominator by an LCD, which is x plus h times x. And so when you do that, you end up with x plus h times x to the first fraction, leaving you with just an x. It's kind of hard to see there. But this is x, and when you multiply this to the second fraction, the x's reduce, leaving you with minus x plus h. And in the denominator, you just leave it h times x plus h times x, just like this. And then, lo and behold, in the numerator, anything with any term without an h reduces away, the x minus x. But when you multiply negative times h, you get a negative h left over in the numerator. And then the h's cancel. And again, that's the goal. Get rid of that h, gone. So what you're left with in the numerator now is negative 1 over x plus h times x in the denominator. On this slide, we have a function that is graphed over here. And just to bring it back up, you can tell it's a function because it passes the vertical line test. And so what you're asked to do is find the information for the following graph. And this includes domain, range, increasing intervals on which the function is increasing, decreasing, or constant, some evaluation going on here, and then you're asked whether it's even, odd, or neither. All right, so for the domain, I'm going to bring in my trusty straight edge. So I have my straight edge here. And what I'm going to do to find the domain is start as far left as the graph will go. And you can see that since there is this arrow over here pointing to the left, right here, that means that this graph will go forever left. And forever in mathematics is infinity. And because it's going to the left, it'll be negative infinity. So this graph will start at negative infinity, and I'm going to keep traveling across this graph. Every x value is being hit, and I'm to the right side of the graph with this arrow now. And that arrow is telling me it's going to go forever right. So forever right is positive infinity. That means the domain will be from negative infinity to positive infinity. And if you're going to write an interval notation like this, infinities will always get parentheses surrounding them. All right, so now the next thing we need to look for is the range. So I'm going to take my trusty straight edge here, get it as close as I can, there we go. And to find the range, you're going to start at the bottom of the graph and report back some y values. So we'll go bottom up and report back y values. I don't think I mentioned this. The domain is the set of all x values, and the range is the set of all y values. So it looks like here that the lowest y value that I will find on this graph is negative 3. So I'm going to start out at negative 3, and I'm going to put a square bracket around it because at this point right here, there is a closed dot, something that looks like this. And a closed dot means we include that particular value. So we include negative 3 as a y value for this graph here. Now the question becomes, how high does this graph go? So it looks like you travel up, up, and right over here on the left side of this graph, it looks like it tops out. And you want to say that the biggest y value is 3. But I would like to draw your attention over here on the right side of this graph. You see this arrow? We talked about it already, going to the right forever. And that's what allowed us to say the domain goes to positive infinity. But this arrow isn't only going right, it is also going up. So if this graph were big enough, eventually this graph would be above this portion over here. So while we would start with the range at -3, when we get to this point right here for the right arrow, it goes up forever. So the top portion of this range would be infinity, up forever. All right, so we've gotten that out of the way. And I should tell the difference between a closed point and an open point. So an open point on a graph might look something like this. And if that were ever part of your domain or range, we would use parentheses around that instead of a square bracket like we did over here for the -3. All right, that being said, want to go ahead and start talking about increasing, decreasing, and constant intervals. So the cool thing about increasing, decreasing, and constant intervals is that they are just little domains. So what I'm going to do is first I'm just going to mark the graph. I'm going to use blue ink here. And I'm going to mark the graph. Constant means the graph is flat. Well, the graph is flat all of here. And the graph stops being flat right there. So I'm going to draw a line down to the x-axis. And when I'm going to mark on the x-axis, that is constant. I'm going to then see what happens after that. And I'm going to do this part in green. After that, this graph is decreasing. That means it is going down left to right. So I know it's decreasing this whole time. So I'm going to draw a line up to the x-axis, and I'm going to draw a D there. So I know that this is my decreasing interval. And then finally over here in red, after this decreasing portion, it changes to increasing. And in fact, it increases forever to the right, just like this constant portion is constant forever to the left. So now all that needs to be done is that the intervals need to be reported back. So it's constant from -infinity over to -2, decreasing from -2 to 1, and increasing from 1 to infinity. So let me take care of this ruler and write all that stuff down. So there are the intervals, and my straight edge is gone. Finally, we have some evaluation that should happen here. We're trying to find an f of -3. So this is like thinking of it as an ordered pair. You want to think of this like what y value is paired up with this particular x value. Well, if x is -3, that's right here. Where is the graph? Well, the graph is up. There is the point on the graph that has an x value of -3. What is the y value of this ordered pair? 3. So the answer here is 3. Similarly, if you are trying to find an x value, right, so down here this one say find x, so f of x equals 1. Well, this is a y value. We're looking for an x value that's paired up with a y value of 1. So if I come over here, I see this point has a y value of 1, and way over here, this point also has a y value of 1. So we're going to have two answers for this. X will equal -1, because that ordered pair is -1, 1, and x will also equal +5. That's because way over here, the x value is 5 when the y value is 1. You can try these other two and tell me whether this graph represents a function that is even, odd, or neither. The answers here for these other two and the last one are -2. If you find out where x is +2, that's right here. You follow it down to the graph, the answer is -2. Which x value is paired up with a y value of -3? Well, the y value -3 is here. That's paired up with an x value of 1. And this graph is neither odd nor is it even. And you can tell that because this graph is not the same to the left as it is to the right. But also, if you decided to spin this graph 180 degrees right on its head, it would look like a completely different graph. So this is neither odd nor even. On this slide, we're asked to find a lot of the same information here. And I'm just going to go through and put up some answers, and you guys can work through it yourself to see if you understand these answers. So first, the domain starts as far left as -4. So this time there is a stopping point to this domain. So it'll be -4. But as you can see, the graph goes forever to the right. So that means it goes all the way off to infinity. The range starts as low as the graph can, which in this case is -2. And that other graph in the previous slide, there was an arrow pointing up. But on this graph, this arrow is pointing directly to the right. So this graph will go above this particular y value of 1 all the way up until 4. The graph is increasing between -1 and 2. Right here, it's going up. So the increasing interval will be -1 to 2. The decreasing interval will be here from -4, that's where it starts, all the way over until -1. That's when it stops. And the constant interval is right over here, where it's flat. The constant interval starts at 2 and goes forever to the right. So 2 to infinity. And I didn't mention this on the previous slide, but when you report back intervals where a function is increasing, decreasing, or constant, you noticed I used parentheses here for every single interval. So you will use parentheses for those intervals. Let's see here. F of -3 is +2, and that is because the x-coordinate -3 is paired up with the y-coordinate +2. That point is right there. F of 2 is +1, and that's because when x is 2, that's right here, when x is 2, the y-coordinate of this graph is 1. So we need to find x so that the y value is -3. That's this next one. Well, this graph doesn't get down to a y value of -3. So there isn't an x that'll do this for us. So we will just say that this is undefined. But finding x where y equals 1, that's a whole different story. That can be happening right here. And I would guess that x would be -2.5, somewhere in that area. But also, where is the y value equal to 1? This entire portion of the graph. So if x is bigger than or equal to 2, then the y-coordinates on all of these points here are 1 forever. And again, this graph is neither. It doesn't have any y-axis symmetry or rotational symmetry.